Point of purchase displays. Design phase. Great ideas can be generated anywhere by anyone. Often they are submitted as a sketch. The challenge is to convert a concept into something more tangible while still retaining the creative intent. Pratt designers work the concept sketches into a viable display through 3D modeling. Designers at Pratt use computer-aided design, known as CAD, to develop electronic die lines for each component used in a display. All point-of-purchase displays are made of an intricate puzzle of interconnected components in order to accomplish the creative goal. These are designed piece by piece, where a change in any given part usually has design implications in the connecting parts. Once designed, the components of the display are electronically sent to a sample cutting CAD table. Component parts are cut on the table piece by piece. Components are then assembled to create a prototype of a display. This is the control point where actual product is tested for actual fit. It is also important to give consideration to the display's survival through the supply chain. Insulating the display against damage while transporting to market is of paramount importance. To determine if the display is able to hold up to the rigors of warehousing and transportation, various tests like the vibration test seen here are performed to simulate long-haul transport. In addition, tests are performed to test warehouse stacking strength. After a successful ship test, final electronic die lines are sent to the art agencies, who place approved art into the structure of the die lines. While art is in preparation at the agencies, additional design work is performed to generate assembly instructions to be used at the pack-out facility. These instructions enable the assembler to meet the intent of the design and enable correct product placement. Point of purchase displays. Production phase. The physical receipt of pre-approved art from the art agencies and separators marks the beginning of the production phase. The art package is checked in by the Pratt project manager. This critical step is performed to verify that the art or part number is correct and that art is on the correct die line. Color references are checked at this point, and color targets for print process are confirmed or generated where needed. Art is then released to the printer for production. In sync with this step is a pre-production process. The list of components, each having a separate die line, is checked for accuracy against a bill of materials, also known as a BOM. These are verified to ensure that they are using the correct die, number, color, print, and type of corrugate. Once this information is verified, production is ordered. Two main types of tooling are flexographic print plates for direct print and a cutting die. This can be either a round rotary die cut or a flatbed cutting die. Flexo direct printing. Many but not all of the components which contain art are printed flexo direct. This means that printing is performed directly on a corrugated sheet. This particular flexo press has a capability of printing 7 colors at a medium-high resolution. Stacks of plain corrugated sheets are lined up into the feeder section and fed into the press. In this type of printing, a single color is assigned to each of the 7 print stations. Even though 7 colors can be used, this specific component only requires orange and black. Ink is contained and mixed constantly while being pumped into the print stations. Periodically, sheets are pulled and checked for uniform ink and color density, with adjustments being performed where needed. Sheets are then stacked at the end of the press and are ready for die cut operation. Litho-laminating. Some corrugate printed materials use another process where art is pre-printed using a high-resolution process called lithography. The art is pre-printed on thin 80-pound paper. Sometimes these are referred to as litho labels and are procured in advance. Once received, they are stacked in the laminator machine. This laminator contains a glue cylinder over which the label passes. The label then meets up with and becomes adhered to a corrugated sheet. Sheets are then stacked at the end of the machine and are ready for the die cut operation. Rotary die cut operation. This process applies to printed as well as unprinted parts. There are two styles of die cutter. This particular machine is a rotary die cutter. The sheets to be die cut are stacked in the feeder section of this machine and then pulled through, causing the rotary die to turn as it passes. This creates the creasing and cutting functions required to shape the corrugate into a working part. Scrap from this process is collected via a vacuum system for recycling. Parts are then stacked and sent to be prepared for shipment. Flatbed die cut operation. This process also applies to printed as well as unprinted parts. This particular machine is a flatbed die cutter. The sheets to be die cut are stacked in the feeder section of this machine. The sheets are pulled through one at a time and placed over top of the flat cutting die. A platen comes down and stamps the corrugate sheet into the die. This stamping creates the creasing and cutting functions very much like the rotary die which shape the corrugate into a working part. Parts are then stacked and sent to be prepared for shipment. Folder gluer. A small percentage of display components have designs where glue is required. An automated folder gluer like this one is the best and most economical way to glue when required. Most shipper containers require glue, as well as some graphic display boxes. Pratt Display. Accelerate to retail. Do something great for the environment.